In this system of equations, we're going to take a look at the addition method. In the addition method, we're going to try to take both equations and add them together and see if we can cancel out the x or y. So what I'm going to do is just take the second equation and I'm going to rewrite it underneath the first one. So we have 2x minus 3y is equal to 8. And if you notice, if we add them up, the y's would cancel each other out. So I'm going to add both equations together. So 4x plus 2x is 6x. Y's cancel out equals 24. Then I divide both sides of the equation by 6. X is equal to positive 4. Now in order to solve for the y, so I have the x part of my, not my vertex, but my intersection. Now in order to solve for the y, I'm just going to take that x value and I'm going to plug it in to one of the equations. It doesn't matter which equation you pick. I'm just choosing this one because I have some space over here. I'm going to plug a 4 in for the x. So 2 times 4 minus 3y is equal to 8. And I'm going to solve for y. So 2 times 4 is 8. Minus 3y is equal to 8. Subtract 8 from both sides of the equation. 8's cancel out. We're left with negative 3y is equal to 0. Divide both sides by negative 3. Y is equal to 0. So my ordered pair is 4, 0. Now there's a certain circumstance that you may run into as you're solving these. You may try to add them together and it looks like they're pretty close, but they don't quite cancel out. So let's take a look at one of those. So if I have x minus 3y is equal to 0, and then the other one is x plus 10y is equal to 13, and again, I'm going to take the second one, write it underneath the first one. So x plus 10y is equal to 13. You'll notice, obviously the y's don't cancel out, but the x's, they're both positive. They're not opposites or inverses, so they don't cancel. So what I'm going to do is I'm going to take the second one. It really doesn't matter which one you do it to, and you're going to multiply it by negative 1. That changes all the signs in that problem. So if I rewrite them, I'm going to leave the x minus 3y equals 0 alone. And then the second one, I get negative x minus 10y is equal to negative 13. Now, if I add them together, the x's cancel out, and I'm left with negative 13y is equal to negative 13. Divide both sides by negative 13, y is equal to positive 1. And now I got to take one of the original equations. Again, doesn't matter which one, so I'm going to use the first one this time. The x minus 3y is equal to 0. Just to show that it doesn't matter, and I'm going to plug a 1 in for the y. So I have x minus 3 times 1 equals 0, x minus 3 equals 0, or x is equal to positive 3. So my answer, the intersection of those two lines, is at the point 3, positive 1.